Hello, so we are going to review a homework question first before we get started with this week's lecture.
Great, thank you. So for 10-1, it's like x1, x2, sigma 1, 2, sigma 2, 2, n1, n2. And so how that pertains to the demo, kind of like, how do I divide out those different variables that are provided in order to get the different populations?
Sure, if I understand correctly with this question, perhaps the main difference compared to the demo is the demo was working with a data frame and
Yes.
creating all of these inputs compared to this textbook homework question, which really it provides you all of those inputs already. So that the key difference is rather than you calculating the mean and the variance for two different groups, this is creating all of those inputs for you. So it's pretty much just jumping ahead a step and doing some of those different like Python manipulations that you would do if you didn't have the inputs provided for you. So I'd say that the key difference is just knowing how to work with that function. So let me get that open. And did I get your question right?
Yes,
Okay.
thank you.
That's encouraging. Because a lot of the similar approach will be taken once you kind of get the structure for what to do. Okay. So I am just getting the other demo open. And I will share my screen again. So we're talking about how in this case we had, this is from the demo where we were looking at the folks who get approved and rejected for a credit card, where we created two separate means and standard deviations to be used in this formula here, compared to in the homework where it gives you these values as inputs. So really, instead of creating these mean and standard deviation for the two separate groups, we'll just need to know from this homework that, sub 1 represents, let's say this is the average of people who got it approved for a credit card, and anything with sub 2 represents the second group. So you would just need to plug and play with those numbers into the formula.
Okay, that's helpful to like split it. Should I actually define using code what each one kind of like X1, X2, just so that when I run those codes for the larger formulas, it's already defined?
It depends how you're tackling this problem. I definitely, I think using Python is sometimes straightforward, but I know for other students, it might not necessarily be the approach they want to take, because really you could do this by hand and just use like a calculator to input it. But if you do plan on using a function like this, you would need to define those inputs if you wanted to, but also even just like walking through this function a little bit more might help give you a better answer there, because really this is just looking for specific numbers. So if you just wanted to take, like, I'm just saying as if that was one mean and this was another, you don't even need to like put in variables here, because the variable just represents a number, and then you're using this function and it pretty much is like a placeholder for all of these different inputs.
Okay.
So it's just taking whatever you do want to input and running this formula on it. So if you wanted to create a variable to save each input, or just write in the input itself, since we're not really working with this too much further after like that question itself, that might be a good way to do it. Because something like on the final, it'll be something similar to this, where you might want to save it as a variable. But for the intent and purpose of this homework question, you could probably just have the number directly here. You don't necessarily need to save it as another variable.
Okay. Okay, so that's helpful to know that the sub one and sub twos are the two different populations. In the future, should we consider all variables that are numbered sort of sub one, sub two, sub three as their own subset within that data set?
I see where the confusion might have came from, of even just knowing that, hey, these are referring to two separate groups. I don't know if you could always make that generalization that they'll be from the same, in this case, this said these were drawn from from a population. So you could assume that these were two subsets from the same population. But I would say anytime there is a subsetted number, it probably is referring to, another subset.
Okay. Okay, thank you for letting me know.
Yeah, so that was a long-winded way of saying probably, but not guaranteeing. It mostly depends on the question structure itself. Like today, we'll be getting into comparing lots of different subsets within a population. So then you'll see like X sub 1, X sub 2, 3, and 4. But that might not always be the case if you're reading something somewhere else, and it might be talking about like 5 different variables, and it might have each subset as a variable there. So I would say usually anytime there is a subsetted number, it's talking about more than one, and there's some type of grouping that exists, and it's talking about two separate groups.
Okay.
And these are great questions to talk through, because yeah, understanding just what this syntax actually means, I think is more of a hurdle than like, what do you do with it after that? Because the rest is kind of just been this same type of approach of calculate the test statistic, formulate it as a hypothesis. Does it, is it evidence to reject the null hypothesis? And to what degree is it significant?
Exactly. The process I'm getting clearer and clearer about, but the actual grouping and original data sorting of this was more my question. I could see from your demo that it was about splitting, but because the homework didn't include a data set, it was like, I take your demos very literally. So when I look at the homework and I'm like, oh gosh, where do I go from here? But that's super helpful. Thanks.
Okay, but that's good to hear kind of like where we're aligned. So that sounds good. That was the, where we clarify things too. So it's good to hear just like, the consistency of like, how do we tackle this once you have the inputs, organized. That's good to hear.
Yes.
So it sounds like we're in a good page. And actually today will be the last class we really talk about this whole hypothesis testing framework, and it will get us to the last module for this semester of talking about ANOVA, or analysis of variance, where it takes a lot of these concepts of looking how much do things vary compared to each other, and taking the same type of framework of like significance of variation and putting it into this ANOVA framework. So a lot of these things are pretty related, but today we'll dive into some interesting tests around like the chi-square distribution specifically. But any other questions from last week's homework before we dive into this week?
That's it for me.
Okay, well, thank you very much for bringing that to the surface, because I know a lot of students probably had similar questions. Alrighty, so I will get started with presenting. I'm going to just end this recording so we can have lots of smaller chunks of videos.